Hello, today I'm going to show you how you can use our tool Vermeer to debug a faulty C program. So here's a simple program. At the end of the while loop we have an assertion saying the variable b should have a value smaller than 4. Though it actually has a much larger value when we execute the loop. So why is that? Well, I suppose it's obvious for this program, but let's see what our tool Vermeer tells us. All the steps I'm going to show you are performed in one go. I run them separately so you can see what's going on inside the tool. The first step is that the tool generates a trace of the buggy execution. The output trace is an executable C program. In fact, all the steps of our tool produce such programs. That's really useful if you want to run other analysis tools on the generated traces. Okay, let me open the trace. In the produced trace, the loop has been unrolled and function calls have been inlined where possible. So we end up with a simple linear trace. But there is still a problem. We are calling the library function apps here, for which we don't have the actual source code. We handle this by creating a concretized trace, which means we track the effect of the function call while executing the trace and then log that effect back into the trace. So let me open the result, which is a new trace program. Since we only know the effect of the apps function on the encountered inputs, we add a conditional which ties the inputs to the outputs. This way we don't lose the control flow dependency between these values. Also notice that the program environment, including all external inputs, has been concretized and logged into the trace. Now I show you the really cool feature of Vermeer. It automatically generates an explanation of the bug in the trace. Vermeer reduces the full trace to only 3 lines. Let's take a closer look. The trace explanation is structured into blocks of individual instructions from the trace that are important for explaining why the trace failed. The first line of each block gives us some information about the state before entering the block that is useful for understanding the bug. Then there's the line number and the actual instruction. So here's the explanation of the trace. We start by setting b to 2 on line 7, giving us that b is greater or equal to 2. Then we go twice through the loop. At this point something interesting happens. The property b greater or equal to 4 holds throughout the rest of the trace. Therefore Vermeer concluded that all further iterations of the loop were not relevant for understanding the bug. So Vermeer tells us exactly what went wrong in our original program. The assertion failed because we went through the loop at least 2 times. Now let's take a look at a more realistic example. What you see here is the full source code of the Unix stream editor SED. This version of SED contains a bug caused by a missing initialization of a global variable. Okay, let's run the tracer and see what happens. The program crashed with a seg fault. Let's take a look at the generated trace program. Phew, the trace is over 8,000 instructions long. This looks more like a proper challenge. In this case, we didn't have a failing assertion, but we did have a crash, so let's take a look at the last instruction. Aha, we must have dereference an invalid pointer. Let's add an assertion stating the pointer must be valid before we dereference. The trace will still abort, but this time with an assertion failure, which Vermeer can then explain to us. Okay, so let's run our trace explanation algorithm on the annotated trace. First I run the trace concretization and the actual explanation. Nice, we reduced the trace to only 7 instructions. So let's take a look at the result. Okay. Here we see the 7 blocks with the instructions that caused the seg fault. In fact, the explanation produced by the analysis tells us exactly what went wrong in the trace. We started by assigning null to the global variable last regex. This indicates that there is a missing variable initialization. We then store last regex into memory, then pass the value through a call to last address, research, research2, and here we go, index into a struct based off the pointer and crash. That's it for today. I hope you'll find Vermeer useful for debugging your programs. Please visit our website to learn more about the tool.